So in this part we are going to see the next mechanism, which is the elimination-addition mechanism. Okay, so I had told you previously that there are two types of mechanism. One is the bimolecular displacement mechanism and the other one is the elimination-addition mechanism, which can even be called as Benzyne mechanism because this takes place via a benzyne intermediate. Okay, I had told you what benzyne actually means in your previous classes, but still we'll see the structure of benzyne in the forthcoming slides. Okay, so when does this bimolecular displacement mechanism takes place? That basically takes place when your aryl halide consists of electron withdrawing groups attached to it. Okay, or in other words, I can say that if your aryl halide consists of activating groups, which has to be electron withdrawing in nature, then this particular reaction takes place via your bimolecular displacement mechanism. Okay, but what happens if there is no electron withdrawing group present on your aryl halide? Then you have to either employ drastic condition, for example, you have to use highly basic condition, or the reaction can take place only if the temperature or pressure is high enough. Okay, so if I have to carry out the nucleophilic aromatic substitution of my aryl halide in the absence of an electron withdrawing group, then the reaction through which it actually proceeds is not bimolecular displacement, but it follows a totally different mechanism which can be called as elimination-addition mechanism or the benzyne mechanism. Okay, so now we'll see what exactly elimination-addition mechanism is. Okay, so what is elimination-addition mechanism? Just like your bimolecular displacement mechanism, this elimination-addition mechanism also takes place in two steps. Okay, so if you consider your aryl halide, the first step is the elimination of your halide to give you an benzyne intermediate, and the second step is the addition of your nucleophile to give you your substituted product. Okay, but if I just see this particular reaction, I would say that if X minus has to get removed, then where did this new bond come from? Okay, that's the question that you would be having in your mind. Okay, so let's see how this new bond has formed. Okay, so the new bond in benzyne has to be formed by some other means. Okay, because you very well know that halide is electron withdrawing in nature, so when it has to break up, it will leave along its electrons. Okay, so it is electronegative, it will leave with a pair of electrons, and suppose this was the only case that is happening, then the carbon carrying your halide ion would have become positive. Okay, but a positive carbocation is not generated in this case. Okay, so there should be something else that is happening in this particular reaction. Now let's see what actually happens. Okay, so it is not as simple as we have seen. It's not just one step, but within the step there is something that is happening. Okay, so over here, elimination again consists of or comprises of two steps. Okay, so in the first step you would see that your nucleophile abstracts a proton which is ortho to your leaving group. Okay, in this case the leaving group is your halide. Okay, so the proton which is ortho to your leaving group is being abstracted by the nucleophile, and this gives rise to a carbanion. A carbanion intermediate is one which consists of a carbon carrying a negative charge on it. Okay, so in the second step, what happens is when this carbanion intermediate, that is the carbon carrying the electron pair, that gets delocalized over the ring, the halogen bond, that is carbon halogen bond, slowly breaks up. Okay, so once this carbanion tries to stabilize itself by delocalization of electrons, this halogen has to leave along its electron pairs. Okay, and that is how a benzyne intermediate is formed. Okay, so in the second step, what happens is your benzyne adds up the nucleophile, okay, giving rise to a carbanion intermediate again, and that carbanion quickly takes up the proton from the nearby ammonia molecule and gives you your substituted product. Okay, so elimination addition mechanism takes place in two steps, and within each step there are two more steps. Okay, so elimination means elimination of proton and then elimination of your halide. Okay, addition means addition of the nucleophile and then addition of the proton. So if you consider the overall reaction, you would see that only your halide is being eliminated. The proton that is being eliminated in the first step is being added up in the second step. So overall reaction is the proton is eliminated, added, so it actually nullifies. Okay, so you just say that halide is eliminated and nucleophile adds to your intermediate. Okay, so as I told you that bimolecular displacement mechanism is different and elimination addition mechanism is different. So why it has to be different? Okay, and what kind of aryl halide actually give this kind of mechanism for nucleophilic substitution? Well, if you see the steps, the mechanism of this reaction, you will see that before this carbon halogen bond is even broken, a proton is abstracted by the nucleophile, right? So this can happen only when this carbon and halogen bond is strong enough, that is, it is reluctant to break. Okay, so that can happen only if this halogen is fluoride. Okay, you very well know that carbon fluoride bond is very strong and it takes a lot of energy to break the carbon and fluorine bond apart. Okay, but if I had carbon and iodide bond, then carbon iodine being a good leaving group, it would just leave and it wouldn't follow this kind of mechanism. Okay, so it would rather follow bimolecular displacement mechanism rather than this benzyne mechanism. So this is an important criteria, okay, for elimination addition mechanism to take place. Your carbon and halogen bond should be strong enough, that is, it should break very slowly. Okay, so only then abstraction of proton is possible and then this breaks up in a very slow step. So if you just consider these two steps, your elimination step is a slow step and the rate determining step. Okay, so formation of benzyne intermediate is a slow step, and if there is anything that could actually stabilize this benzyne, will speed up the reaction. Okay, so now let's have a view of the structure of the intermediate that is formed, that is the structure of your benzyne. As I told you before, this is the new bond that is formed in your benzene ring, right? And this new bond is formed by the sideways overlap of your sp2 orbitals on the carbon. Okay, and this new bond, since it is formed by the sideways overlap of your sp2 orbitals, it is weak in nature. Okay, and this bond has no interaction with the pi electron cloud which is above and which is below your benzene ring. Okay, so this bond lies at the sides. It has no interaction with the pi cloud which is above and below the ring, and hence this bond is not so strong. It is weak in nature. Okay, that is why your benzyne becomes highly reactive, and if there is any group which could actually react with it, it would prefer to react and become much more stable molecule. Okay, so benzyne formation takes place in two steps. One is elimination of proton and then elimination of your halide ion. Okay, that's all in this particular slide. We would see the evidences for benzyne mechanism in the next part. Thank you.